presentation with yourselves. And we can take it from there. So just to begin with, I would like to also say that please feel free to add any questions that you may have using the chat function throughout. If you could kindly stay on mute as well through the presentation until we come to the Q&A session. And we can then have an interactive discussion and answer any queries that you may have on the information that's presented today. To begin with, I would like to just cover the introductions. So today, you are seeing myself, Monica Gary, Asset Care Center Manager at Optimal. I lead the strategic growth division of the business and also work closely with our strategic partners for technology solutions. With myself, I have Ismaila Kwamena. Ismaila, can you give a few words and introduce yourself, please?
Yeah, hello everyone. I am Ismaila Kwamena. I am a graduate asset reliability engineer with Optimal. I'll be co-presenting with Monica today, and I'll be going through the simulation of the digital twin and also be presenting the results as well. Over to you, Monica.
Thank you very much for that, Ismaila. Okay, so what are the key purpose and objectives of the webinar today? So we're looking to provide you with an overview and a live demonstration on how key asset management challenges in energy and utilities can be addressed using simulation digital twin technology. And we'll pay specific focus on total expenditure optimization element through the case study that we will be presenting as part of the demo. On the agenda today, we have an introduction into Optimal and also the Optimal and Cosmo Tech partnership. We will cover a little bit of background on asset management challenges in energy and utilities sector, and also look at a quick overview of the Cosmo Tech Asset simulation digital twin technology. From there on, I'll be handing over to Ismaila to run through the actual live demo and look at the TOTEX optimization case study for electricity power distribution network client. And we'll finish up with an interactive Q&A session as well. So, without further ado, a little bit of background on Optimal. As a company, I've been established back in 2015 here in Aberdeen, UK, where I'm based. Since then, our operations have grown and expanded with a subsidiary established in South Africa back in 2018. Optimal, we have a team of asset management and reliability experts who carry the domain knowledge of the full asset life cycle. We are multi-sector experts as well in the field of asset management, with a particular focus on complex enterprise asset data management solutions and reliability engineering. Our research work with the University of Aberdeen and collaboration with Tshwane University of Technology, as well as track record of various asset management optimization projects in oil and gas, mining and nuclear sectors, has focused our understanding of asset management efforts and their maturity. At Optimal, we are passionate about providing bespoke and innovative solutions in physical asset management field to enable asset owners to maximize value from their assets based on their specific requirements and operating context. On the slide here, you see the breadth of clients that we have worked with over the years. Key projects looking at maintenance strategy optimization and development, materials management, spares inventory projects, as well as technical writing and training. Moving on from there, let's talk about partnerships. So partnerships for us are a key element of our business model and provides us with access to cutting edge yet proven technologies. Cosmo Tech being one of these partnerships. Cosmo Tech are a digital twin technology provider, and we have joined forces last year. Cosmo Tech have established itself as a global reference in the modeling, simulation, and optimization of industrial systems. With the development of simulation digital twins, decision makers can virtually test their action plans before implementing them, obtain an optimal executable strategy to achieve their goals and meet their KPIs, and be able to show every step of this operational plan with total transparency. Cosmo Tech provides simulation capabilities of unique accuracy that enables managers to optimize the performance of asset management activities. This in turn allows for existing maintenance policies to be challenged, alternative strategies tested under operational constraints, and provides a means for unified operations and maintenance planning in an integrated framework. Ultimately, digital twin technology allows asset owners to maximize the power of optimization by managing complex assets and organizational data that's being processed by the digital twin. So through this partnership, you ultimately get 2 for 1, so to say, Optimal as a trusted expert in asset management and Cosmo Tech as the advanced digital technology provider coming together to provide services for different industries that we work with together. Moving on, looking at asset management challenges in the energy and utilities sector. So assets are at the core of the energy and utilities sector. However, many companies are still dealing with the same problems that they had a few years ago, lacking a single comprehensive view of their assets and processes. This in turn leads to poor performance and the inability to access the true cost of assets and plan their maintenance. Additionally, existing methods often fail because they do not incorporate business context changes related, for example, to energy transitions and the consequences that can be seen on how the infrastructure is operated, thereby downgrading the reliability of the predictions. Gaining a greater visibility in your overall asset management is key when considering elements of your organizational ecosystem and how those will affect the long-term decision-making and strategic plans. Key challenges in the energy and utilities sector revolve around operating aging assets and infrastructure, the need to align strategic decisions with the operational plans, and the ever-increasing requirements for additional investment in network modernization and expansion. So, how should asset owners and managers go about breaking down these various barriers between processes, strategies, and operational constraints and manage the complexity and wealth of associated asset and organizational data? Digital twin technology can provide the basis for bringing these various elements into a single source of truth via a dynamic replica of organizations' processes, resources, and strategies. Feed into that the different constraints and you'll have a platform that allows you to simulate various scenarios and in turn significantly improve the decision-making process to improve overall operational efficiency. Moving on to the Cosmo Tech Asset solution specifically, we can say that Cosmo Tech Asset is designed to scale from the start and takes into account your overall asset base. Through that, you have this capability to model at multi-scale levels, looking at different time horizons, as you can see in the diagram on the slide, and allows for a look into behavior granularity as well. You can also make this evolve over time, ensuring its alignment and responsiveness to your specific business needs. You can run and test unlimited scenarios that predict all possible outcomes of future investment plans and come up with the optimal plan to balance performance and cost in line with the KPIs and goals of your company. Ultimately, this technology can provide you with a simulation digital twin of your overall operational system, from which you'll gain clear insight into the best asset mapping to specific lifecycle strategies and the optimal resource allocation you need in order to reduce your maintenance and costs. Cosmo Tech for energy and utilities focuses specifically on 3 key elements: maintenance optimization, asset business planning, and integrated asset planning overall. Cosmo Tech Asset is perfectly positioned to assist in the maintenance optimization activities, development of the asset business plan, as well as assist in the integrated asset planning. Having gone through the background and overview, we would like to raise a few questions for your consideration throughout the remainder of the presentation. What is your current level of confidence in current business plan that you have? Have you identified the strategy to match the performance targets given by your management without requiring additional resources? And most importantly, do you feel like you can easily tune resource allocation in this complex business environment that we're currently working with? I'm now going to hand over to my colleague Ismaila to take you through a demo of a case study for the electric power distribution network, where the key goal was to reduce asset management total expenditure. Over to you, Ismaila. I am going to stop sharing my screen and Ismaila will take over the presentation, so apologies for the little interruption that we're going to have.
Yeah, thank you very much, Monica, for that introduction. I'll be taking over now to present the case study. I'll be sharing my screen now. I assume we can all see my screen now?
Yes, Ismaila.
Okay, yeah. So for this demo, I am assuming the role of an asset manager in charge of an electric power distribution network. This network is made up of 5,000 assets, which includes 280 transformers, and it supplies electricity to 8,000 customers. After a recent corporate review, I'm being asked to explore ways by which the TOTEX, which is the overall expenses, could be reduced to save capital to support a network extension. And maintenance activities are performed on the transformers occupy on these 280 transformers. Maintenance activities performed on them occupy a large part of the overall expenses. So we decided to investigate how we could reduce the cost of maintaining these transformers. Looking deeper into the transformers, the two main categories are the medium and low voltage transformers. The medium voltage transformers generate most of the profits and has more customers dependent on it. It is therefore advisable to reduce the expenses on the low voltage transformers where the risk associated are quite low. Also for this network, where most of the assets employ a run to failure strategy, the only asset group which could be subject to a budget cut is actually the transformers, since they are preventive and condition monitoring maintenance on them. The challenge here, however, is to reduce the budget, but also make sure that the corporate objective is met. So it's making sure that the reduction in the expenses does not affect the required delivery of electricity or compromise the quality of service being delivered. So the three main aspects to consider here are the performance, the budget, and the risk. How do we achieve the right balance between them? So using a Cosmo Tech asset solution, we are able to create various scenarios and simulate them to understand and also determine which is the optimal strategy to proceed with. Over here, so we have three main scenarios here. This is the business as usual. This is the current strategy that we're using here. We created two additional strategies, two additional scenarios. And the first one, in the first scenario, we applied a budget cut to the condition-based maintenance activities being performed on the low voltage transformers. In the second scenario, however, we are trying to find the ideal inspection frequency. So we reduce the inspection frequency on the same set of low voltage transformers from yearly to every 5 years. So over here, these inspections are performed every year, and we are trying to reduce them from every year to perform these inspections every 5 years. All these scenarios are simulated over a period of 40 years to understand both their short and long-term impact. But you can also create an unlimited number of scenarios until you identify which scenario is the optimal, like which scenario is best for your plans. Okay. So in order to understand the actual impact, it is better to consider all the business key elements, such as the network, the risk involved, also the resources available, and then the overall asset management. So I would like to switch now to the user interface, where I would analyze the results of these three scenarios.
Palabras, la conjugación de estas dos cortes nos van a mostrar cómo
Okay. I think someone has their mic on. Okay, so starting from the first results. So looking at these first results over here, we have a financial overview of all three scenarios. So this scenario is our business as usual scenario. We have a scenario where we applied a 50% budget cut to the maintenance activities, to the condition monitoring maintenance activities. And then we have this scenario here where we reduce the inspection frequency from yearly to every 5 years. So this blue section here represents the raw OPEX, the yellow represents the raw CAPEX, and then here we have the red represents the NDE. So the NDE stands for non-delivered energy, which represents the risk of energy not being delivered to the required population. And looking at this picture, it is quite evident that the scenario with a 50% cut, with a 50% budget cut, would result in a higher risk. Over here, we can see it results in a higher risk of energy not being delivered. Whilst this scenario here, where we reduce the inspection frequency to 5 yearly, reduces the TOTEX, the overall expenditure, and also has a lower risk of energy not being delivered. Okay, so now moving on to the operational side of things, we have a look at the number of failures associated with each scenario. So this small section here is the business as usual scenario. That is what is currently being used. We can see here that it only produces just one failure. Whilst the budget cut here, a 50% budget cut results in more failures. That's about 100 failures, as you can see over here. And a scenario with a reduced inspection frequency also results in more failures as well. So yeah, from a financial point of view, this scenario is good, but also we have to consider the impacts from the operational point of view as well. So that because there are more failures occurring. However, for an asset manager, a certain number of failures is acceptable, provided there is a good redundancy system in place on the network. So if the failure occurs, then we have a redundancy system where the failure will not impact the system. So the real impact occurs when this failure causes an outage or compromises the quality of service being delivered. So this chart, that is why this chart on the right here is needed to know the amount of energy not supplied with each scenario. So we can see over here that in the first 10 to 12 years, there is almost no difference in any of the scenarios. So sometimes it makes a lot of difference when we simulate on either short-term or long-term basis, because we can see that for these first years nothing happens, but then after these years, there is a quick rise in the risk of energy not being delivered associated with the scenario where there's a 50% budget cut. So yeah, with the budget cut, you save a lot of money, but this also means that as time goes on, there's a reduction in the maintenance activities that will be performed on these assets. So typically, maintenance activities such as replacements or repairs could be scheduled for like the next 3 years or 5 years. But a budget cut would prevent these activities from being performed when the time comes, and this would actually accelerate. This will accelerate the aging of the asset. So with time, this leads to an increased number of failures, and also increase the risk of energy not being delivered. Okay. Yeah. Now, so this chart also represents the. Sorry for that. Yeah, this chart over here also represents the operational aspects of things here. So here we're looking at two things. We're looking at the physical age. We're looking at the physical age and the apparent age of these assets. To understand the difference between the physical and the apparent age, we can assume two people buying two cars, two people buying the same car at the same time. One person maintains the car well, with good servicing and good maintenance, while the other person does not carry out any maintenance or servicing on the cars. After 3 years, the physical age of both cars will be 3 years, but the apparent age of the car which wasn't maintained or serviced will be higher than the service car. So basically, the apparent age refers to the actual condition of the assets or the health. Yeah. So this same analogy is applicable here, as we can see that with the business as usual, with a scenario where we applied 50% budget cut, the aging rate is much higher than the other scenarios, such as the business as usual, or the one where we reduce the inspection frequency. Also, looking at the apparent age over here, we can see that the business as usual has the lowest average for the overall it has the lowest average for the overall network. And these numbers over here are important when calculating the health index of the assets. Okay, I move on to this graph down here at this bottom. Let's close this over. Okay, so looking at this graph here at the lower right corner, this describes the asset life cycle over the years. First, we look at the scenario which we currently using, so the business as usual scenario. So the reason why these lines are going up and down, this means that the apparent age of the asset is going up and down. What happens is the apparent age starts going up. It means it's getting into a worse condition, and these points represent the inspections being performed. So inspections are performed at these points, and then from what is discovered from these inspections, maintenance activities will then be carried out, and then the apparent age improves. So that is why this line falls, and then until the next inspection is performed, and then maintenance activities are carried out all the way till we have to replace the asset. So once we replace the asset, then the apparent age falls down here. And so with the new assets, obviously, in the first few years, we do not carry out any maintenance activities. So that is why we have this straight line over here, because no inspections or maintenance activities will be carried out because the asset is new. Until we start carrying out inspection activities again, and then maintenance activities will be carried out to the next replacement. The same thing applies for this scenario where we reduce the inspection frequency to every 5 years. However, we can see that we don't have this zigzag here because we decided to do these inspections every 5 years instead of every year. So we have this straight line here because no activity is performed for 5 years. So we go all the way here. And then an inspection is performed, and then maintenance activities occur, and then this improves the health of the asset. However, the only risk associated with this scenario is that looking here in this case where a replacement was carried out because an inspection was performed here, if here we do not perform any inspection at this point, we wouldn't know that there will be the need to carry out any replacement. So there is that risk of failure occurring without we knowing, because we did not carry out any inspection. But as I mentioned before, a certain number of failure is acceptable, provided that we have a good redundancy system in place. Okay. Yeah, so this chart over here shows the types and number of operations that are performed for all the scenarios. So this blue section here represents all the inspections that will be performed. The green one represents the repairs that will be performed, and the yellow represents the other replacements that will be performed. So we can see that the business as usual scenario is a scenario where we have most of the operations being performed. So there are more operations being performed here than these other two scenarios. But we need to also understand what is the efficiency of these scenarios. That is what we can understand from looking at here. So this bit here, this donut chart here, represents the operations cancelled. There are various reasons for which operations could be cancelled. This could include non-availability of human resources, no budget available, or operational conflict. So operational conflict is basically when there are too many maintenance activities scheduled on the same asset at the same time. So we can see that with the business as usual, there are more. There's around 31, almost 32% of the activities of the maintenance activities scheduled are cancelled due to various reasons. It could be operational conflict. Whilst with the budget cuts, with the scenario where we have budget cuts, we can see that is where most of the operational conflicts occur, and many operations are cancelled. So basically, we've reduced the budget, and that means that there would not be enough money to carry out these maintenance operations. On the other hand, when we look at this our scenario where we have the inspection frequency reduced to 5 yearly. That is where we have the least operations cancelled. So this means that maybe the fact that we've reduced the inspections to be performed every 5 years, this allows other scheduled maintenance activities to be performed as well. So this graph here gives us an idea that it is also possible that sometimes the usual or the business as usual scenario, the general strategy that is being implemented could be carrying out more maintenance activities than required, as you can see here. So more maintenance activities are being scheduled, and in the end, not all of them are being able to are able to be performed. And finally, we look at the last graph here, which is the human resources, and this gives us an idea of how many full-time employees are required to carry out the necessary maintenance operations. Yeah, so these are the results of the scenarios. Now it will be good to understand what actually happens inside these models. So what is the input of these models and how we came up with these results. So I'll just go in here. Yeah, so over here we have various tabs such as the classes, human resources, sustainment actions, sustainment plans, advanced studies, and settings. I'll start with the classes and by selecting one of the asset classes. So over here we have a general overview of all the asset classes that we have defined for this model. And inside this section, sorry. We can see the failure rate, which is over here. We can see the failure rate over here associated with all of the with a specific asset class. So over here we can see that the initial part, this is where the asset is fairly new, and so there are no failures occurring. And over here, this is when failures start to occur, and then failure starts rising rapidly. So we get to this pink section here where too many failures occur, and it is actually more cost efficient to replace the assets. In this, when the asset gets to this section here, it is more cost efficient to replace it than keep maintaining it. We can then go on to our human resources tab over here, where we specify the types of human resources that will be carrying out the various maintenance activities. So for example, we look at the cable maintenance team. Over here, we specify which region this maintenance team will be working, what skill these maintenance team possess. So this specific maintenance team can carry out inspections, they can carry out replacements and repairs, and also which asset classes this maintenance team would be working on. And finally, the weekly the rates at which they will be operating as well, how much it would cost for them to be working. We then go on to the Sustainment Actions tab over here, where we define the actual actions. So for example, here, we have something like an inspection, or let's say we can define an inspection, a replacement, or repairs. And then we defined if to perform this activity, to perform this maintenance activity, will there be any outage required? So do we need to shut down the whole system to perform this maintenance activity? Is this inspection going to be carried out on the entire element, or just only a specific part of the assets? And also the action scope, if it's a global one or a local one. We also get to define how long this maintenance activity will take, the supplier cost involved, and the duration is over here. The duration, we get to define the duration here, and also the supplier cost, and we also get to define which teams will be performing these tasks. We can also see in the sustainment plan where we have all our maintenance policies defined. And since we are focusing on reducing inspection frequency on our low voltage transformers, I would go into the condition-based maintenance for the low voltage transformers over here. Yeah, so inside in this section here, we get to name the type of maintenance that will be the type of maintenance activity we'll be performing, the asset class that we are performing this maintenance activity on, and then also the duration of the simulation. As I mentioned earlier on, we are performing this simulation for a period of 40 years. So we have a start year of 2015 and an end year of 2055. And in terms of the type of also strategy being implemented here, so we can, whether this plan is a condition-based maintenance. So the condition-based maintenance is where we inspect the assets and then we take decisions based on the findings of these inspections. Or we can also have a preventive maintenance where we have fixed time replacement. So for example, we could have circuit breakers being replaced every 5 years, maybe because previous data has shown that these circuit breakers start having more failures after 5 years or maybe after 6 years. So we decide to have a fixed time replacement every 5 years. So this type of strategy is the preventive maintenance. And then we also have the creative maintenance, which is more like the run to failure. So we just allow the asset to run until it fails, and then we fix it. And the final option is the renewal. This is more like an investment plan, which deals with replacing a certain percentage of the assets after a certain period of time. So all these 4 types of strategies could be selected here. In this case, we've selected a condition-based maintenance. Yeah, and this is where we define also the inspection frequencies as well, whether we want to make it yearly, or over here we have 52 weeks, which is referring to yearly, but if we want to change it to every 5 years, we would change it here as well. Yeah, so yeah, and then we can go on to the advanced studies tab. So far what we've had a look at, what we've been looking at are what if scenarios. But look at with the advanced studies tab, we can investigate how-to scenarios. So the main difference between the what-if scenarios and the how-to scenarios is with the what-if scenarios, you have the problem and you try to investigate various scenarios till you identify the optimal strategy to go ahead with. However, with a how-to scenario, you define the problem, and then the software performs an analysis of to determine which strategy is actually better for you to proceed with. So you just define the problem, and then the software performs the analysis and comes up with the possible options. So this is your problem, and these are the possible options of how you can achieve this goal that you are trying to achieve. Okay, I would go back into the presentation mode over here, where we would be. Yeah, so with the current, with this case study that I just presented, a reduction, it resulted in a reduction of 8% in the TOTEX, which is the overall expenditure. However, there are many more benefits which could be derived from using this digital simulation software.
Oh, sorry.
Not just a 360 prescriptive simulation, so it gives you an entire overview on all your assets, and also from an asset obsolescence management point of view, you can also achieve 50% to 80% annual capital investment reduction. From an asset business plan point of view, we can have you can achieve the asset manager can achieve a 10% reduction in capex in the capex and in the opex, and also from the maintenance optimization point of view, the operational conflict could be reduced by 20%. Yeah. Okay. So that brings us to the end of this webinar, and we'll be taking the questions now. We have helping me would be partners from Cosmo Tech and also principal asset reliability engineer, Mike Hobbs from Optimal.
Thank you very much for that, Ismaila. Hope everyone had a good insight as to how the system operates and what data goes in the back end to get the outputs for the various scenarios that we run. So once again, thank you, Ismaila, and thanks for all to listening. We do have a few questions that have been typed in, so I'll commence with the first one. And ladies from Cosmo Tech, if we could kindly come to yourself for support in answering this particular one. So Dragan has put a question saying that the part of the grid presented in the case study is rather radial. Do you have a reliability grid simulator being able to simulate a real power grid considering power flow and reliability together?
Yeah, sure. So the simple answer is no. Basically, the representation of topology is a simplified one. We do not model power flow. We model grid redundancy and topology in order to constrain outage planning. For the grid, in terms of grid reliability, with our model, we can simulate the consequences of failures on asset at the system level. So we do bring sort of grid reliability and in terms of like service level, I guess. But no, like regarding a reliability grid estimate, regarding the simulation of a power flow, like we don't do that for sure.
Yeah, shall I add to that a little, Monica? It's a good question. I understand the question, but totally agree. It's not. It's not a tool that's trying to replace the sort of calculation or modelling that you might do in terms of the power flow. It's the reliability relationship. So what is being modelled is the combinations of events that could lead to a degradation or a loss of the delivered power or capacity or whatever the chosen units are. What I would say is that most things can be modelled. The skill is really in the application of those relationships. So most things can be tackled. There aren't sort of straight out of the box relationships to cover every combination or situation or arrangement of equipment. The tools can be used in the power industry, oil and gas industry, a whole range of industries. So it's very much in how you represent the relationships and then run the model, keep running it, look at the different outcomes and make a judgment. So really what you're doing is you're testing the robustness of various scenarios. And one way I would describe that is a colleague at Cosmo Tech calls this situational awareness, which is a really good way of explaining or showing that you're using different scenarios to test the robustness of your system against various things, either failures, different investment programs, whatever it is that you can choose really. And do that as an asset manager and make an informed decision on that basis.
Thank you very much for that, Anne-Sophie and Mike. Dragan, does that address your query, and would you like to add any comments before we move on to the next question?
Thank you for the answer, but my understanding is that basically you don't have this tool. Why I ask this question is that from Hydro-Quebec's perspective, I am from Hydro-Quebec, we are working right now on building this power grid reliability simulator connected with power flow and all those electrical constraints. So it is a huge challenge, you know, and putting that together is not an easy way. So for that reason, I would like to know whether or not you are able to do that, but I see that there is still work to be done. So why it is important is that basically respecting this constraint n-1 and all that redundancy in the grid and how to calculate this interrupted megawatts and the value of load and so on and so on it will also allow us to define the criticality of assets in the grid. And in this regard, so it is work in progress, I see. So thank you very much.
Thank you. You mentioned criticality there. That's a good one. That's another one that's a natural outcome from this. Having constructed a model and validated in that it gives answers that can be trusted, criticality it naturally falls out in terms of what contributions it makes to unavailability or a loss of process. So criticality, determining criticality in a complex situation is a very good use of these sort of tools.
Thank you for that, Mike, and thank you, Dragan, for your input as well. The other question we have moving on is from Anu. Anu's saying, informative session, is there a limit of number of what-if scenarios that could be used within the simulation? Ismaila, I know the answer as well, but I'll let you come in on that.
Yeah, so honestly, there is no limit. You can create an unlimited number of scenarios till you find the ideal scenario or the optimal scenario to proceed with. So yeah, there is no limit on the scenarios. Yeah, you can create as many scenarios and compare various scenarios alongside each other. So you have the results. You can have results on both sides, and you can just compare these scenarios. Yeah, so.
Okay, thank you for that, Ismaila. Another one for yourself, Ismaila. The last slide showed the resources needed. Can a resource limit, say 10 operatives, be imposed whereby a failure would have to queue awaiting a repair team? If all were already in use, this would impact process availability capacity. Can you kindly address that?
Could you repeat? That is, if there is no resource available.
No.
Yes, that was my question, Ismaila. So yeah, if you've got a limited number of people available, can you put that constraint on the model?
Yeah. So you specify how many people you have to work on each of the assets. So as I was going through the operational conflict, so it was one of the reasons why maintenance operations could be cancelled. That could be due to lack of resources or availability of the resources as well. So you define the amount of people that are available to work on certain resources, the time that they are available to do so as well. So yeah, this is all taken into consideration when you are building up the model.
That's great, thank you.
Okay.
Thank you for that. Another question we have in from Fabrice. Thank you for that. So Fabrice is asking, can strategies be set up specifically by asset family? And does the condition-based scenario integrate the actual condition of assets? Ismail, can you kindly address that?
Yeah, so most of that is true. The setting up the model, you can set up a scenario based on the asset families. And what happens behind the scenes, like when you are compiling the information for this model, is you actually take into consideration the real life operating condition of these assets. So you consider the environmental operation conditions as well. So if, let's say, this asset is operating in an environment where maybe it could be subject to corrosion, maybe it's operating in maybe salty waters, or it's operating in the open, you have to indicate all these factors as well, just to make sure the model is as realistic as possible, so that the rate of failure that you are putting into simulate is the actual or very close, almost the same rate of failure in actual real life. So yeah, that is the main goal of having the digital twin, to make sure that what we are simulating is a replica of what we have in actual life. Yeah.
Thank you for that, Ismail. Fabrice, do you have any comments to add? Okay, we'll move on to the next question. Nitek has put in a question, between what if and how to scenarios, is there any limit on the number of elements that can be simulated simultaneously? For example, expected OPEX and MTBF and required production, or they have to be simulated individually?
Currently,
Ismail, can you cover this?
Yeah, so in the how-to scenarios, the two main the two main categories that could be carried out simultaneously could be the OPEX and also maybe trying to identify the ideal inspection frequency. But in terms of the mean time between failures, I don't know if our Cosmo Tech partners would comment on that. I'm not sure that could be done at the same time while simulating with the budget cuts, while trying to find the ideal budget cuts as well.
I think you can't. Yeah, I think you can't at the moment. I'm not sure how many, like the limit. Sorry, that you can have simultaneously. Apologies. For what if, I know it's definitely there's no limit for sure in terms of how to scenarios. I'm not entirely 100% sure. I'm happy to take that question and ask our senior product owner for assets and get back to Patel on this.
That's fine. Thank you. Yeah.
Thank you, Ismaila and Sophie, for the inputs. Another question we have is, are the various parameters added, such as the fail rates and repair time, varied according to statistical distributions? Can the user select any distributions, such as normal, long normal, etc., etc.?
Yes. So in the section where we view the asset classes, where we get to see the failure rate, for each asset class, you can actually specify the failure rate and also determine the type of distribution for these assets. Yeah, it's possible. Yeah.
Sorry, Ismail, you broke up there just at the end of the sentence. Could you kindly repeat?
Yeah, I was saying that in the failure in the asset section where we get to see all the asset classes, it is possible to define the various failure rates for all these for all the various asset classes. So yeah, you can specify the various distributions, the failure distributions as well for the various assets.
Fantastic. Thank you very much for that. So that's all questions that we currently have on the chat. Those who are on the call, please feel free to unmute yourselves and ask any questions directly if you would like, or any comment that you would like to make based on the demonstration that has been shown by Ismaila. We'd welcome any feedback that you may have.
Yeah, I may have a question, Olivier Blanc from Hydro-Québec. I'd like to know if you model the impact of maintenance strategies on the failure rate of assets, in a way that if you have such preventive maintenance strategies for inspection, for example, which will be the impact if you change the frequencies of those inspection on the failure rate of the asset itself? Is there a kind of model to optimize the frequencies of periodic inspections?
Yeah, so that was actually one of the main points of this case study. So we were actually trying to find the optimal inspection frequency as well. So sometimes you could be carrying out too many inspections. If you're carrying out a yearly inspection on an asset, which might not necessarily require a yearly inspection. And if you try to reduce it as well, if you reduce it from 1 year to 5 years, and maybe it could happen that because of the failure rate, a failure could also occur at maybe the 4th year. There is a risk of the failure occurring before you carry out the next inspection. So yeah, you get to understand these things when you simulate. You get to see when these failures occur, and if you can accommodate these failures depending on your system. If you have a redundancy in place that if these failures occur and it does not have an impact on your system, then yeah, you can allow these failures to occur. But if not, you just have to reduce. You just have to move the inspection forward to make sure that it happens before the failure occurs. I don't know if that answers your question.
Okay, so that basically using the failure distribution that you determine if you're in a good range or.
Yeah. So you specify the failure. You have to specify the failure rate for these assets. Yeah. So using that information, that is when the interface will predict when the failure is most likely to occur. Yeah.
Okay. Thanks.
No worries.
Thank you for the question, Olivier, and thank you, Ismaila. Would anyone else like to come in before we go ahead with the closing of the event? Please do not hesitate.
It's really quiet.
Okay. It's quiet, it's okay, no problem. We won't be forcing anything. So I would like to thank everyone for attending. As I said at the beginning of the presentation, and I know a few people have joined later on as well, we will be sharing the recording post the session. And we are very much looking to not just end at the point of the webinar. We're looking forward to having additional engagements. And if you have any questions that arise after reviewing the recording, or any questions that you have that you haven't put forward just now, please feel free to get in touch with us. We're here to answer, and we're also working very closely with partners Cosmo Tech themselves. So both parties would be willing to answer any questions that you may have and look into the possibilities of how we can support your operations and your businesses in an effort to optimize everything that we have to do in these tricky times that we're working with the conditions for the business being volatile. Thank you, Ismaila, for delivering the demo. And thank you, Anne-Sophie, for contributions from your side, and Mike in the Q&A session. That should be all from our end. Thank you very much once again. I hope you all stay safe and stay well, and we'll look forward to welcoming you to other events as we have them coming up. Ismaila, any final words from you?
Yeah, I would like to thank everyone for attending this webinar. I hope you found it really interesting and useful as well. And like Monica said, we're willing to extend these conversations behind the scenes as well for any possible collaborations. Yeah, thank you, everyone. Thank you, Monica.
Fantastic. Thank you, everyone.
Thank you.
Take care and goodbye.